Exercise number 1 is about treatment of data and graphs of relationships. Significant figures. Much of physics is about experimentation, observation, recording, analysis, and reporting of data. Being an experimental science, it requires measurements with express degree of accuracy. The measure of accuracy is expressed in terms of the number of significant figures. Hence, we need to know how to express a measurement or even process data with the correct number of significant figures. Counting the number of significant figures. All non-zero digits are significant. We take on the following examples. 95 has 2 significant figures. 1245 has 4 significant figures. 3.2991 has 5 significant figures. And finally, 13.5 has 3 significant figures. Number 2. Zeros before the first non-zero digit is insignificant. 0145 or 145 has 3 significant figures. The 0 before 1 is insignificant. 0.0004 has only 1 significant figure. The zeros before the 4 are insignificant. Number 3. Zeros after the last non-zero digit of a decimal number are significant. 430.0 has 4 significant figures. The zeros to the right of 3 and the 0 to the right of the decimal point are both significant. 1.1000 has 5 significant figures. The zeros to the right of 1 are all significant. Next, zeros between non-zero digits are significant. 5072 has 5 significant figures. The 0 between 5 and 7 are significant. 10,004 has 5 significant figures. The 3 zeros between 1 and 4 are all significant. Number 5. Zeros to the right of a non-zero digit and to the left of an implied decimal point are insignificant. 900 has only 1 significant figure. The zeros after 9 are not significant. 34 million has 2 significant figures. The trailing zeros after 4 are insignificant. Next, zeros to the right of a non-zero digit and to the left of an expressed decimal point are significant. 40 has 2 significant figures. The 0 to the right of 4 and to the left of the decimal point is significant. 6,000 has 4 significant figures. The 3 zeros to the right of 6 and to the left of the decimal point are all significant. Rounding of numbers. The first rule, if the number to be dropped is less than 5, we drop the number and the succeeding digits. 15.347 rounded off to the nearest tens, meaning 1 decimal place. Since the number following after 3 is 4, which is less than 5, then we simply drop the number 4 together with the succeeding digits. And so, it is equal to 15.3. If the number to be dropped is greater than 5, we drop the number and the succeeding digits, but we need to add 1 to the preceding digit. Example, 224.3479. We round it off to the nearest hundredths or two decimal places. The digit following 4 is 7 is greater than 5, so we need to add 1 to 4. We drop 79, but we have to add 1 to 4. Hence, the rounded number is 224.35. Next, if the number to be dropped is 5 and preceded by an even number, we just drop the number. However, if the number preceding is odd, we add 1 to the preceding number. Example, 142.5 rounded off to the nearest ones. So since the number to be dropped is 5 and it is preceded by an even number, we simply drop the number 5. Hence, the rounded off number is 142. Next, 738.2350 rounded off to the nearest hundredths, meaning two decimal places. Since the number to be dropped is 50 or 5 followed by a 0, and it is preceded by an odd number 3, then we need to add 1 to 3. Hence, the rounded off number is 738.24. How do we find the sum or difference of measurements with the correct number of significant figures? The number of significant figures of the sum or difference is determined by the least number of decimal places of the figures involved. Example, say we are to calculate the sum of 15.354 and 12.1. 15.354 has 3 decimal places, while 12.1 has 1 decimal place. As ordinary numbers, the sum is 27.454. But the sum should be expressed in 1 decimal place because between 15.354 and 12.1, 12.1 has the least number of decimal places, which is 1. So it is just right that in our answer, 27.454 must be rounded off to 1 decimal place. Hence, the sum with the correct number of significant figures is 27.5. Next, we determine the product and quotient of measurements with the correct number of significant figures. In multiplication and division, the number of significant figures in the answer is the same as that of the quantity with the least number of significant figures. So for example, we are asked to evaluate 0.134 divided by 5.2 multiplied to 173.0. Using our calculator, it will give us 4.4580769. But we ask, what should be the correct answer with the right number of significant figures? Since among the factors 0.134, 5.2, and 173.0, 5.2 has the least number of significant figures, which is 2. Hence, our result should be written with 2 significant figures, 4.5. So we round off 4.4580769 to 1 decimal place because it will give us 2 significant figures. Selecting and reporting data points. When we conduct an experiment, we do several trials and report the gathered data. However, it is common that in our repeated trials, we get some figures that are somewhat far from most of the other data. We call these as the outliers. Therefore, we should be careful in reporting our data, seeing to it that as much as possible, it is free of erroneous measurements. Hence, We disregard these two measurements of 12.75 and 12.03. So we report 5 data points excluding 12.75 and 12.03. As you observe, all the measurements cluster with each other. Plotting or graphing of data points is one way of determining whether there is a relationship that exists between variables. The resulting graph of data points involving two variables is referred to as a scatter diagram. Common relationships are linear, either positive or negative. For a positive linear relationship, this indicates that as one variable increases, the other variable also increases. The increase in one and the decrease in the other suggests negative relationship. The relationship in a more compact form for a linear relationship can be represented by a linear equation called the linear regression line. Other relationship includes quadratic, exponential, and logarithmic. Finally, one must remember that the scatter diagram or the graph must be accompanied by an appropriate interpretation. For the following example, the interpretation reads, the graph indicates a positive linear relationship between the weight and the height. The greater the height of the person, the higher his weight. Thank you for listening.